And the first talk is by Rob Kursinski, and he will speak on the PlanetiQ radio occultation observing system update.
Okay, yeah, I'm going to give a quick update, 15-minute update on PlanetiQ, what we're doing, what's our latest status, near-term future. The team that has contributed to all the stuff we're doing right now. So the outline is a summary of our current and near future capabilities. Just one quick slide on polarized RO, the contracts we're now under, the quick words on the space weather ionosphere pilot report, and then some work we're doing, a lot of work we're doing on trying to improve the impact in the lower troposphere. And we are hiring, so, and I got a slide at the end, but we're hiring, so come see me if you're interested in coming to work for us, work with us. So this is a summary of our spacecraft. The two that we have up there right now that are working are GNOMS 4 and GNOMS 5. GNOMS 5 launched on August 16th. 4 and 5 are each producing about 2,200, 2,200 occultations per day and about 2,700 ionosphere. They're in similar orbits, not identical, but similar. So we're on contract with NOAA to deliver 2,200 now, starting 5 days actually. One thing that's interesting about GNOMS 5, it's got a new capability. It's got a new dual linear polarized antenna on it. So it can do the polarized RO and eventually do some reflection measurements. These satellites, these receivers all track all 4 constellations. Oh yeah, these two carry working thrusters. Unfortunately, GNOMS 2 had a thruster, but it didn't work, and so it fell out of the sky because of the solar max. Yeah, pole-to-pole coverage, and the system is very flexible, and we're continue to have the goal of 20+ satellites and 50,000 occultations per day. We have a very high SNR system, similar, in fact, a bit better than Cosmic 2 with pole-to-pole high SNR, pretty even other than Putin's war in Ukraine. Yeah, so we've got global coverage on this, and the purpose of this is for the lower troposphere primarily. Okay, so this is a quick shot of the satellites. So the first 4 satellites, including GNOMS 4, all have that configuration up here. So high gain antennas, these are individual columns that are tracked individually, and then we combine them on board so we can point them effectively in azimuth to get the highest gain. These are the POD ionosphere antennas. The one thing that's different on GNOMS 5 is we made the decision, and the 6th satellite will do this as well. We made the decision to replace these RCP columns here with an H and a V column here. And so the 2 inputs to the receiver here are these 2 inputs. And this is the rising occultations for spacecraft 5 and setting occultations for spacecraft 6. And so this allows us to do the H and V separately. We also can, just like PAWS, we synthetically create an RCP for regular RO. And this allows us to do the polarized, the pro stuff that Estelle and Ramon have been doing. We're finally getting into that game. And eventually we'll derive some reflection measurements off of this. And these are the first polarized RO measurements. Jonathan has just gotten this calibration working, so these are still warm. On the left is just a case where presumably we're not seeing any precipitation because we're not seeing any shift in the phase delay between the horizontal and the vertical. And the right-hand side, clearly we are. Just this coordinate system is a little different than people may be used to. So this is the impact height and bending angle that we're used to in RO, but the color is telling you how big is the magnitude of the phase delay, the phase shift between the horizontal and the vertical. So you can see the delay, which is presumably correlated with some kind of precipitation. So anyway, those are the that we'll have a poster on that as soon as it gets printed. We'll have it this afternoon. So the contracts we're on a NASA evaluation contract that Melissa mentioned. We're on the RODB2 data order 4 that Natalie mentioned, and we're also on an Air Force contract that I'll talk a little bit about later. And we're hopefully on another contract coming up that we've been selected, but we've got to negotiate. So this is an important slide. I want to make a distinction here. So these are the various contracts. So the RODB2 space weather pilot contract, I'm going to say a few words about that. So I want to make some distinctions here. So we provide level 0 and level 1A products for that, as well as we provide some level 1B products now, and I'll come back to that one. But here's the distinction I want to make here. For RODB2, data order 2, we provide 0 and 1A from NOMS 2 and 3, and we're going to do the same on NOMS 4 and 5. Now, on this right-hand side, this is an important distinction. Because this market is so bloody competitive, we ended up making a distinction here. For the first data order, we provided what we are now calling premium data. That's full SNR. Because the price competition has driven us down, what we've decided to do is for data order 4, what we offered to NOAA was premium and basic. In fact, I think it's, yeah, let me jump to this one, and I'll go back to that. So what we did, believe it or not, is we added noise and dropped the price to the added noise so that we could still meet the NOAA spec and be able to lower the price. But separately, we are selling the premium data. So I just want to make this distinction, and this is an important distinction because when NOAA and NASA are saying they're going to combine their purchasing in the last couple talks, I want to make this clear. The data that NOAA is buying for data order 4 is fine for operational purposes because NWP is not using the high SNR in the lower troposphere. For NASA research purposes, you want the high SNR premium data. And so I need to make that distinction because we were sort of forced into this from a business standpoint so that we could sell the data at the lower price for the operational stuff, but not give the full quality for the lower troposphere. So I'm just, all of us, you guys are all squirming. We were squirming because we just had to do this from a business standpoint. So I just want to make that clear because when NOAA and NASA are not currently buying the same quality data. And that's because NOAA doesn't think that the value of the high SNR in the lower troposphere is of much value operationally. And maybe it's not yet, but we are working on trying to get the value of the high SNR in the lower troposphere. So I just want to make that distinction. It's a very important distinction. We were forced into it, and NOAA bought the lower quality data because it's cheaper, and that's consistent with how it's being assimilated right now. The lower troposphere is not being used. It's being cut off at a high altitude. So just want to make sure everybody's aware of that because obviously this has implications. This slide is also making the point that NOAA is buying level 0 and level 1A data, then UCAR and CDAC are processing that. For the NASA evaluation, we are doing the processing all on the PlanetiQ side with AER. And so we're delivering, and for NASA, we're delivering level 1B and level 2 products that have been processed a bit differently. Yeah, and also the NASA data is going through the final orbit. So it's trying to make it more of a climate quality, whereas the NOAA stuff is near real time. Yeah, so this is the NASA data we're providing let's see. So essentially Confase and ATM Prof, level 1B and level 2. And then on the space weather, we're doing calibrated TEC and scintillations. Also sporadic E's embedded in that, in this Confase stuff. Also, there's surface reflections that we have not, grazing surface reflections that we have not extracted are sitting in this data, in the level 1B Confase data. By the way, I was just talking to Joseph about this. We see a lot more reflections, grazing reflections than cosmic did, and presumably it's because our SNRs are so much higher. And at low latitudes, the number of grazing reflections is about 3 times higher than what cosmic saw. At high latitudes, they tend to be up in the 90 percentile. Okay, so I've already, so basic means 400 volts per volt. We literally add white noise to it and degrade the SNR. Oh yeah, so this is, Jonathan's going to talk more about this. He's giving a talk on our retrieval system. I just wanted to make the point that the UCAR system that's doing the processing right now is actually degrading the high altitude stuff. And I know Jan, they're working on it to change the orbit determination, the clock estimates. But one of the reasons NOAA is chopping our data at like 45 kilometers, and they shouldn't be, is because there's noise is being added somehow in that processing step. So it's making the phase jitter. And so it's degrading, so that the bending angles are noisier at high altitude than they should be. And so when we do the processing ourselves, using real time, let's see, I need to point at this. So the noise when we process is 6.5% or 7%, and when UCAR processes it, the noise is higher, and that's because of noise is somehow being added in the orbit and clock determination step. But like I said, Jan, they're working on that, and I don't know if it's up and running yet or not, but it will be. I think will be soon. Space weather pilot. So the evaluations just came out from that activity that ended on, well, supposedly ended August of 2023. The TEC, I'm just summarizing some of the report. I'm not going to read all this. I mean, basically the TEC looked good, a little bit slightly out of spec, and that was processed by UCAR, by the way. So again, that was level 0, level 1A data processed by UCAR. Yeah, so go to the next. On the latency, we take a little bit of issue on the latency thing where they're saying, the report is saying 64 minutes. However, if approximately 40% of our ionosphere occultations do actually meet the latency, and our intent was that NOAA use that, and we provided PodTech 2 data that we calibrated ourselves that met the latency spec, but NOAA took all the data and then did the specs on that. The reason for this chart is we've only got 2 ground stations, and it turns out when we try to meet the latency spec of the 30-minute median, there's a swath of the Earth that we don't meet, just because you have to go sometimes a whole orbit before you come over the site. So if we put in another ground station, which are available in Northwest Canada, I believe this whole thing gets filled in. And we can obviously add more ground stations if there's a need to reduce the latency. And I will also mention that we've begun development of a real-time satellite-to-satellite link, so we can bring the data down in seconds. That's 2 years away or 3 years away, but I mean, we're developing it. So, because there's a lot of DoD specs. Sorry, okay. Yeah, this is a detail, but we can do a better job of setting the threshold. Vu mentioned that, of setting the threshold when we trigger the data to come down for the high rate scintillation data. The trigger is not optimum right now. Let's see, how much time do I have? 1 minute. I'll just say we're working a lot on improving the RO impact in the lower troposphere with the high SNR. we're focused on these three items right now of this issue with the numerical instabilities. The large bending angles, by the way, are being underestimated. JPL sort of report on that, but we're seeing it statistically. And of course, ducting produces a negative bias. This is how much of the data is being rejected if you set the threshold at 50% of the ducting. Anytime you come within 50% of the ducting, you're throwing away an enormous fraction of RO data in the lower troposphere. And let's see else. I wanted to make a point here. I'm going to skip it. So the things we're working on right now, we have an Air Force contract. They're paying us to work on this lower troposphere. So we're working both on the retrieval side and on the NWP side. And this is work jointly with JCSDA, but I think Ben may be the only one that's really aware of that. But we've got to start interacting. Basically, we're focused on getting better retrievals of the large bending angles, detecting whether this ducting is present. When the ducting is detected using phase method, plus the grazing reflections, as Josip and Eric have pointed out, and then actually implementing Sergey's non-local excess phase forward operator in the JCSDA, which was based on stuff that Steve developed earlier. So this is a big effort for us, and we're going to stick this in JCSDA and hopefully make all this work and get impact in the lower troposphere. And high SNR is critical, and I'm going to talk about that in a talk on Tuesday. So this is a summary of what we've been doing. Lots of occultations, 4,400 occultations. We're finally in this dual pole stuff. We will be generating GNSSR at some point with the dual pole antenna. We're on contract with NOAA and NASA. We're working on this lower troposphere to try and get this information into the end. That's why the Air Force funded us. They want to see the data get into the lower troposphere, get into the NWP. And these are other talks. Jonathan's giving a talk, I think, today. I'm giving a talk Tuesday. We've got a poster on the polarized result. Jonathan's got a poster on the transmitter and receiver clock estimation, and a space weather poster on this in the second session. And as I said, we're hiring. We're finally getting some money, so we're hiring. So that's it. So anyone who come see me if you're interested in coming to work on a variety of things.
Okay, thank you. We don't really have time for questions. I think
Kristen, you can talk. We can talk. Oh, okay. All right.
John, you want to ask a question? Quick one.
So interesting decision about the premium music data volume. So does that also mean that you have plans to sell polarimetric data as a different buy?
So I actually was on one of the slides that I blew through. For the NASA, Will McCarty was interested in somehow expanding the initial evaluation to include that, but it's a thought. You know, now that it's starting to exist, we need to have that discussion with NASA to expand that. That would be the initial thing, to stuff it under that NASA. All right.
Chris, yeah.
So just to have a high SNR receiver,
yeah, we can't hear it on.
I'm yelling. So just to get that, to understand the problem, you have a high SNR. You have a high SNR receiver, and because the contract negotiations didn't work out, that when you are on purpose, the data
For the NOAA contract, that is right. No. It's we are. Oh, because we're cutting off the bottom, you mean? But look, turn around. Oh, that's right. So we're only tracking down to -200 straight line versus the full high SNR is tracking down to -350 like Cosmic 2 does. Okay. All right.
So that means that you are delivering modified level 0 data because it's not the original level 0.
That is a true statement.
Okay. So
we will have the level 0 archived on our system, but what we're delivering.
and if someone comes with the money, you will be willing to sell it.
Absolutely. And in fact, that's the concept that operationally NOAA is saying this other stuff's not valuable, and yet we think it is valuable specifically for research, and it will eventually hopefully become valuable for operational capability.
We're adding more effort to do all that.
Yes, it's a painful decision, but we had to do it financially to be competitive. The price of the market is so low, you can't.
Adding more value doesn't
Christian,
lower
let me just interject here to the audience that because we made the decision on CDP, what they're providing still exceeds the IDIQ specifications of what's in the contract. So
Yeah, so we designed it to
leave it at
match
that.
to be above the contract requirements.
Yeah, I'm still flabbergasted really why having good data and degrading it on purpose, taking away the opportunity for future researchers.
No, we didn't take away we have not taken away the possibility for future research. In fact, we want the future research, but NOAA is buying it for operational purposes, not research purposes. Now, if NOAA wants to change their philosophy on this, that would be great. But right now, we're sort of separating just operational quality versus research quality.
So may I
So-
add a quick comment, because I think this is critical, and I would like this at least somehow being one of the discussion topics or NWP subgroup. And I already sent email to the subgroup lead, and if anybody is concerned, and I also hope that NOAA can have representative into that discussion. Thank you.
Yeah, no, I absolutely agree. We were forced into this. The community needs to understand, what we were forced in, from a business standpoint, we're forced into, and the implications need to ripple through the community to figure out what does it want, what does it not want, that kind of thing. We were very uncomfortable in making it. We all went thumbs down, and then the business people said, no, we're doing it.
So Rob, how can researchers? It's me here over here.
Oh,
So yeah, how can researchers get hold on the full data?
well, in theory, NASA's supposed to purchase it.
NASA buys for US.
Yeah.
Yeah, so there's not a great solution sitting right now, but we were forced into this, so we'll have to just figure out because we desperately want the community to develop the ability, and we've got this Air Force money to develop the ability to use the lower troposphere in NWP. That's why we built the system. So it's a strange situation because we want the researchers to be in there helping getting this working. But NOAA's only buying the stuff that they see is valuable today in the operational system.
One more question from Eric.
No, I defer.
Just waiting for a microphone. Yeah, we will definitely discuss this in the NWP group, because I'm a bit shocked. This change is going ahead on Wednesday. We
Yep.
are all here.
Yep.
I just learned about this, so it's
Well, we
from
only
a
went on
NWP
contract.
perspective, it's really, really time-wise annoying. I'm sorry. It's why? I mean, all this changes constantly, and it's not that we just assimilating commercial data.
So
We also-
can I interject? A lot of this is not necessarily just on the company, but that was a decision that NOAA made as well.
Yeah, but
So
it
I
was
know-
not clear from the original email sent out last week that this is a difference to what has been done.
So we purchased the data. This is an operational contract for operational purposes. The pilots are more for research purposes. NASA is more for research purposes. So we understand the whole research community benefits from our data, but our number one customer is NSIP. And that's what we have to support first and foremost. Everybody else benefits from that data. That's, I mean, if you have any more questions, you can reach out to Natalie Laudier or somebody with an SAE about that. They made their business decision based upon the marketplace. You know, that's all I have to say about
I know
that.
a lot of this can be deferred to an NWP subgroup, but the piece of this that seems critical to me is that now we have made the distinction between buying data for operations and buying data for research. And that is a Rubicon, right? Because in general, scientists don't have any money. The research world has always been dependent on the operational world to get our data. That would always be the case with public sector missions. So here we see the clear distinction between public sector and private sector missions, that you've built this wall between research and operations based on pricing and contracts that really doesn't allow the scientists to have access to a raw material that has always been taken for granted. You know, so maybe the question really for this group is, you know, how to inform the research community of the new constraints that they're going to have to live under in the future. There's no question that it takes at least 5 years to launch a public sector RO mission. I mean, this is what we heard earlier today. And it's already 2024. If you wanted to launch in 2029, you would have to start today. And no one has named a mission. Congress hasn't approved it, so that's not going to happen. So the expectation is that when Cosmic 2 degrades, it will be replaced by purchased commercial data. That's sort of the default hypothesis if nothing else happens. So it's critically important that source of information that comes from radio occultation will transition from something that's equally a research mode and an operational mode resource to something that may be purchased for operations in a way that does not make it appropriate for research, right? And so that, I think, is the real critical issue here.
Right. My
Okay.
talk is never going to end.
Yeah, I just would like to add that everyone in this room also should think about climate and about a sustained radio occultation system for climate, because that hasn't been discussed so far. So I know we are in the NWP session, we are in the commercial data provider session, but please also keep in mind that we need a sustained long-term system for climate, and we need all the information from the RO data, all the metadata archived, so that in 20 years, 50 years ahead, people can go back and reprocess the data that are highly important for climate monitoring.
We have to go on. Thank you, Rob.